And here are the parts we'll be using today. Beige PC case, because beige is the best colour ever. Motherboard, 256 meg and 64 meg sticks of SD RAM. Samsung 80 gig and Fujitsu 2.6 gig PARTA hard drives. Samsung optical drives, Mitsumi 1.4 megabyte 3¼ inch floppy disk drive, XP Pro Service Pack 2 operating system, slot 1 450MHz Katmai Pentium 3 CPU. We actually found an I/O shield that fit, or as we like to call it, an arse plate. Creative Sound Blaster CT4810 sound card, a generic ATX power supply with blown caps which surprisingly still works after sitting for such a long time. What a champ. ATI Radeon 9550 AGP 8x graphics card. We've hit a snag, and unfortunately our ATI Radeon 9550 8x graphics card is not physically compatible with the 2x AGP slot on the motherboard. We will have to hunt for another graphics card that is compatible and go from there. Time for some CPU destruction. So we took the CPU heatsink off to check the thermal interface material. Luckily we did, as it was old and barely touching the silicon. And due to Intel's horrible heatsink clip design, socket 478 anyone, we unfortunately managed to break the plastic clips due to them being a one-time use design. But we are planning to 3D print some superior clips in a future video. We could have just left the CPU as is, but we thought we'd rather risk some broken clips than a rare fried obsolete CPU. The cleaning. We use a compressor and a nozzle to clean the dust off our old parts, but make sure to hold any fans still when you blow them with high pressure air, as they are old plastic and they have a tendency to whiz around at a high RPM and shed blades in all different directions, including people's eyes. Ouch. Make sure to wear eye protection whilst blowing any dust out of PC parts, and use a soft to medium bristled brush to remove any caked on old dust that just won't budge with air, and it's all good to go. Now time to clean the CPU heatsink. We use rubbing alcohol and a microfiber cloth to clean the caked on old thermal interface compound from around the CPU die, and a metal scraper to carefully remove the caked on thermal paste from the heatsink without scratching away the black anodizing layer. And we finished it off with some more rubbing alcohol. Good as new. All that's needed now is to apply some new thermal paste and we can reassemble the CPU, heatsink and fan. We use Arctic Silver 5 because it's reliable, reasonably priced and suits our needs for this build. Alright, we've got our heatsink clean, we've got our thermal paste on the CPU, and if we look down through the holes so they line up with the holes in the plastic shroud on the other side, and we grab our broken clips that we broke before from trying to pull them off. Intel had some really bad designs when it comes to their heat sinks, and yeah, this is one of them. Push that down so that goes all the way through. Other side. Do the same with this one. You can hear it crackle and pop, just like rice bubbles. Alright, so we're using the point of view GeForce FX 5500 256 meg DDR graphics AGP graphics card, and we're just going to take the heatsink off and clean it. So first we unplug the onboard fan power, then turn the card over and undo the clips that hold the heatsink on with a pair of pointy nose pliers, and squeeze the clips in, just push them through the board and flip the card over and remove the heatsink from the GPU. Alright, so I'm just going to, if you can see, there's 1, 2, 3 screws holding the fan on. So I'm going to undo those just so we can better clean out the heatsink on this graphics card. And just get the brush and brush out the heatsink, get rid of all that dust. Don't breathe this. Yep, that should be fine. And give the fan a bit of a brush. Grab the screws out so we don't lose them. 1, 2, 3 screws, and then give the fan a good brush out. Alright, so we've screwed the fan, cleaned the heatsink out, screwed the fan back on. Just give it a quick spin, make sure it's not hitting anything, and that's good to go. And flip it over, and we'll clean off the old thermal paste. Let's grab a microfiber cloth and give it a good clean. Get all the old thermal interface material off. Nice and clean, ready to go. And now we'll clean the old thermal interface material off the old the graphics chip, the GPU. Which is not going to be easy. Sometimes it can be a bit stubborn if it's been on there for a while. Might take a few goes, but we'll get there. Alright, now that that's cleaned up, we're just going to apply some thermal paste to that chip, and we will put the heatsink back on. Alright, and just line up the clips with the holes. And plug the fan back in. Unfortunately, when we pulled apart the PSU, we noticed that it's got bulging caps. It's been sitting there for a long time. So, yeah, we kind of screwed before we even start, but we're going to blow it out and then put it on the PSU tester and see if it will give us enough power to do what we need to do today. We use a compressor and a nozzle to clean the dust off our old parts, but make sure to hold any fans still when you blow them with high pressure air, as they are old plastic and they have a tendency to whiz around at a high RPM and shed blades in all different directions, including people's eyes. Ouch! Make sure to wear eye protection whilst blowing any dust out of PC parts, and use a soft to medium bristled brush to remove any caked on old dust that just won't budge with air, and it's all good to go. The testing. Will it explode? She lives! It's alive! Amazing. I cannot believe that that is working on the 12 volt, 5 volt and the 3.3 volt. So you've got 12 volt, one rail, 12 volt, two rail, 3.3 volt rail, another 12 volt rail and 5 volt rail. And they're all getting with an acceptable parameters of power. So I'm absolutely amazed, even with those busted caps, after how long that PSU's been sitting there. The Mobo features. This motherboard features an Intel 440BX Northbridge chipset, an 82371EB Southbridge chipset with a UDMA 33 IDE controller, a Highpoint HPT 366 UDMA 66 IDE controller, allowing a total of 8 PARTA IDE devices to be connected, 3 SD RAM slots, a floppy drive slot, manual overclocking dip switches, 20-pin ATX power socket, slot 1 CPU slot, AGP x2 slot, 5 PCI slots and an ISA slot. At the back of the board is the CMOS chip and the Winbond hardware monitoring chip, and all the caps on the board are in good condition. To make sure that it works, otherwise, yeah, it's there's no point putting in the case if it doesn't work, but I'm pretty positive it's going to work. So we'll slide it in to the slot, push it down till you feel it bottom out. Plug your CPU fan into the CPU fan header, which, if you look closely, it tells you dilly squat. So we'll just plug it into that one. That'll do. And when you've finished and you've slid your CPU in, you slide the two locks up to lock it in place. Now we put the RAM in. We'll stick the biggest stick of RAM, which we've got a 64 meg stick, and we got 256 meg stick of SD RAM. We'll put the 256 gig stick into the first slot. This is SD RAM. This predates DDR400. Very hard to get. I'm lucky that I kept it. So that's 250, and it's expensive when you do find it. So that's 256, and here's another 64 meg stick that I had, just to give it a little bit extra. And that will do for the time being. So we've got our CPU, now RAM in. Alright, so we've got our power supply plugged in, we've got our FX 5500 plugged in, we've got our CPU, 2 sticks of RAM ready to go, and now we're ready to bridge the power button pins and listen for the beeps from our speaker. Single post beat. Nice. The build. I love that sound. Thanks for watching. Don't forget to like and subscribe. Stay tuned for part 2 where we benchmark and test the system.